basically we have one is definition, another is test. So basically test is used to find increasing decreasing nature. What is the definition? Definition says that if we have a function which is increasing, then it simply means that in that interval, if you take x2 greater than x1, that means f of x2 will be greater than f of x1. So this you can understand from the graph like this, that this is an increasing function, and this increasing function has a value x2 here and x1 here. x2 is greater than x1 because x2 is right of x1, x1 is smaller. Now, if you take f of x1, you'll get this as the output, and you take f of x2, you'll get this as the output. Clearly, f of x2 is greater than f of x1 because it is above f of x1. So if x2 is greater than x1, then f of x2 is greater than f of x1. This is what increasing means. That is, f of x2 is above f of x1. If a function is decreasing, then if x2 is greater than x1, then f of x2 is less than f of x1. So here sign reversal. Why is it so? We'll see it from this graph here. Suppose the graph is something like this. This is a decreasing graph. Why is this a decreasing? Because if you take x2 here, which is greater than x1, and if you mark the output, then mark output would be at x2, the output will be f of x2 here, and at x1, the output is f of x1 here. So f of x2 is actually below f of x1. So it is less than f of x1. So increasing means that if the input increases, output is also increases. Decreasing means if the input increases, output decreases. It does not increase. So this is what is the definition of increasing and decreasing. So you can note it down.
Done, sir.
Okay. Now the test. Test says that if function is differentiable, then how you test it, whether it is increasing or decreasing. So the derivative is going to be positive if it is increasing. Reason being, what is the derivative? Derivative is slope of the tangent. So if the function is increasing, slope of a tangent at any point would be having an angle theta. Theta is acute angle here. So if it is acute angle, the slope m is equal to tan theta is going to be positive because it is acute angle. So this is f dash x at any point p. So f dash x is greater than 0. If function derivative is coming out to be negative, then the function is decreasing. Now here again, if we draw a decreasing graph, what we obtain that slope of a tangent would be at any point theta, and theta is obtuse angle. Now tan theta, tan of an obtuse angle is actually negative. So this is the slope, which is f dash x, it is negative. So this is how we test whether a function is increasing or decreasing. Third thing is, sometimes it may be possible that the derivative is equal to 0 in an interval, not in an isolated point, in an interval. So we say that it is neither increasing nor decreasing, it is a constant function. Done? Okay. So if we see a few examples based on this, like we can see a question here. Okay, there is one more thing in NCERT which says strictly increasing and strictly decreasing. So strictly increasing and strictly decreasing means that it cannot be equal to 0. So strictly increasing is that derivative is positive, strictly decreasing is derivative is negative. If it is only increasing, then it means derivative could be positive or could be 0 also. And if it is only decreasing, then it means derivative could be negative or 0 also, because there is a possibility of being constant also. So like if you see an example, increasing could be like this, that the graph goes like this and like this and like this. And strictly increasing means it will always increase, never it will be constant. Again, strictly decreasing means like this. But if it is decreasing, it may be possible that at some point it is constant, then other points it is decreasing. So this is a slight difference between strictly increasing and strictly decreasing and decreasing. And this is the condition difference between these two. Okay. So there's a question like this: find the interval in which the following function is strictly increasing or decreasing. So the one part could be fx is x square plus 2x minus 5. First, we will differentiate it as it is differentiable. So 2x plus 2 we will get. Now for strictly increasing, what we have? We have f dash x is greater than equal to 0. So we'll say that 2x plus 2, which is the derivative, is greater than equal to 0. 2 you can take common and write as x plus 1 greater than equal to 0. So x is greater than equal to minus 1. So this is the condition for strictly increasing. That is x belongs to minus 1 to infinity. Another one is strictly decreasing. If you talk about strictly decreasing, you will say that f dash x is less than equal to 0. That implies that same thing, 2x plus 2 is less than equal to 0. Or 2 common, it goes on the right, x plus 1 less than equal to 0. Or x is less than equal to minus 1. So we say that x belongs to minus infinity, comma, minus 1. And interestingly, this is a quadratic. From 11th, you know that the graph of quadratic is something like this. This is upward opening parabola. So this is a point where this value is x is minus 1. Just write it down. I'm just receiving a call. Okay.
Yes.
Hello, Darnell. So you have written this. So
Yes.
what is important here? If you see the graph of f of x, this graph is an upward opening parabola, x square plus 2x minus 5. And this x is equal to minus 1 somewhere here, where it is becoming minimum. So you can see that from minus infinity till minus 1, this graph is decreasing. It is decreasing like this. And then from minus 1 to infinity, it is again increasing like this. So you can say that our result is correct. It is according to the graph.
Yes, sir.
Similarly, if we see one more question, second part, fx is minus 2x cube minus 9x square minus 12x plus 1. So again, you will do the differentiation f dash x, and you write it as minus 6x square minus 18x minus 12. So minus 6 will be common, and it will be x square minus 3x minus 2. So this will be minus 6, and this will be x minus x square, and then minus 3x minus 2. Okay. So can we do the middle term splitting? We can do the middle term splitting. It cannot be subtracted. It is minus 6x square minus 18x minus 12. Question I have written correctly. Oh, it is a plus. This is also plus. Minus we have taken common outside. So x square plus 2x plus x plus 2. So this will be minus 6, and then x common. So x plus 2 plus 1 common, x plus 2 is equal to minus 6, x plus 2 common into x plus 1. So this is how you write the derivative f dash x, right?
Yes, sir.
Now this f dash x has a sign scheme. How do we do the sign scheme? If you remember, sign scheme of f dash x. So it is having two points, critical points. One is minus 2, one is minus 1. So it will be negative here because it is minus 6 outside. Then negative is below the x-axis, not above the x-axis. It will be negative here. Then it will be positive here. Then it will be negative here. And the graph would be something like this, that this is.
So I don't understand this part. The negative, positive, negative.
This is the sign scheme. This is how we do the sign scheme. If suppose we have this term, so when will it be equal to 0? At minus 1 and minus 2. So what we will do, we will first point those critical points, minus 2 and minus 1 on the number line. This is x dash, isn't it? This will become 0 at minus 2 and minus 1.
Yes.
Okay, this sign scheme we used to do in class 11th when quadratic and all we used to do. So this will become 0 at minus 1 and minus 2. And then since outside there is a minus sign, so we start from the rightmost portion. And the rightmost portion will be the sign which is outside. So negative is outside. So it will be negative. When you will cross the critical points, it will become positive. And then again you will cross, it will become negative alternately. So you can say that the graph is like this. So this is the graph.
So is it always alternative?
Yeah, it will basically here the power is odd, so it is alternate. But if the power is even, it will not be alternate, it will not change. For example,
No.
if suppose it is minus 6x plus 2 whole square into x plus 1. If it is like this, then what will happen? Again, minus 2 minus 1 you will plot. You will take negative here because outside there is a minus sign. Then at minus 1, it will become positive. At minus 2, it will not become negative. It will remain positive. It will not change sign because its power is here even. So if the power is even, it will not change sign. So the graph would be like this in that case. So
Okay.
mostly you will get the questions where power is odd. So this is how we plot the sign scheme. So this sign scheme helps us to determine the sign of f dash x. So this f dash x, as you can see here, is now less than 0. Where it is less than 0? For x belonging to minus infinity comma minus 2 union minus 1 comma infinity. And f dash x is greater than 0 for x belonging to minus 2 comma minus 1. Is it okay?
Yes, sir.
So the derivative is negative for this interval, derivative is positive for this interval. So we will say that the function is, because we are not talking about f dash x, we are talking about fx. So where f dash x is negative, fx is decreasing. In the graph is not of fx, it is f dash x. So fx is decreasing in minus infinity comma minus 2 union minus 1 comma infinity, and fx is increasing in minus 2 comma minus 1. So you can start from here, writing from here.
Oh, so it's done.
Okay, it's done. So below one also done.
Yes, sir.
Okay. So if I give you a question, suppose one question is 6 minus 9x minus x square. Here also you have to find the interval of increasing and decreasing. And another one is x plus 1 whole cube, x minus 3 whole cube. X plus 1 whole cube, x minus 3 whole cube. This is called interval of increasing and decreasing. I'm coming in a minute.
Oh, so is it minus 9 by 2 to infinity for increasing?
Minus 9 by 2 to infinity for increasing. Okay, 1 second, let me check. 6. For decreasing, you are saying minus 9 by 2 to infinity.
So increasing.
No, it is for decreasing. For increasing, it is minus infinity to minus 9 by 2. Because when you will differentiate it, first one let us talk about. You will get minus 9 minus 2x. And if you're talking about increasing, suppose, then you will say it is greater than 0. So minus 9 will be greater than 2x, or you can say that 2x is less than minus 9, or x is less than minus 9 by 2. So increasing is minus infinity to minus 9 by 2. And if you will take decreasing, then you will take the derivative less than 0, which means minus 9 minus 2x is less than 0. So minus 9 is less than 2x, which means you can say that 2x is greater than -9 or x is greater than -9/2. So it is decreasing for -9/2 to infinity.
No. So for the other one, f of x is increasing from 3 to infinity.
F of x is increasing from 3 to infinity. Okay. Let us
And it's decreasing from infinite minus infinity to -1 u -1 to -2 3.
I don't think so. Let us see. Because when you differentiate it, we'll apply the product rule. So x plus 1 cube into 3 into x minus 3 square. And x minus 3 will give you 1. Plus x minus 3 cube into 3 into x plus 1 square. This is what you are getting.
Oh, so I didn't apply the product rule. I just took like one term and the other term and differentiated both. So
No, when you differentiate the function, so this function you have to differentiate. So it is a product of two functions. So you will apply product rule. Now this is u, this is v, as we used to do in differentiation. So you'll first take u, you differentiate v, then you take v, then you differentiate u. Isn't it so?
oh yes.
So this will become 3 common, x plus 1 whole square into x minus 3 whole square common. And inside the bracket, you have x plus 1 plus x minus 3. So you will say 3 into x plus 1 whole square into x minus 3 whole square. And this will become 2x minus 2. So 3 into 2 will be common. X minus 1 into x plus 1 whole square into x minus 3 whole square. So this is what we are getting. We can write it as 6 into x minus 1 into x plus 1 whole square into x minus 3 whole square. Now we have to see the sign scheme. So sign scheme would be, let us see where it is becoming 0. So it is becoming 0 at 1, at -1, and at 3 places. When x minus 3 will be 0, when x minus 1 will be 0, and when x plus 1 will be 0. Now, since the outside sign is positive, +6, so it will be positive, the rightmost portion. Then 3, the power of x minus 3 whole square, it is 2, even. So it will remain positive. It will not change sign. Then 1, x minus 1 power is 1, which is odd. So it will change sign. Then x plus 1 power is 2, which is even power. So it will not change sign. It will remain as it is. So only at x minus 1, where 0, when x minus 1 is equal to 0, x is equal to 1. So this is the critical point. So there only the sign will change. Otherwise, the sign will not change. So this will be positive, this will be positive. Then it will be negative. Then also it will be negative. So this is the sign scheme. After knowing the sign scheme, you can say that f dash of x is less than equal to 0 for x belonging to -infinity to 1 as you can see, and f dash of x is greater than equal to 0 for x belonging to 1 to infinity. So in this interval, we say that it is decreasing. The graph fx is decreasing, not f dash x. F dash x is negative, so decreasing fx, and in this interval, increasing fx. Done?
Yes, sir.
Let us see a few more questions. There is one trig function. I want you to do that also, because somewhere trigonometry is also there in increasing, decreasing. Prove that. Let us prove that question. Prove that y is equal to 4 sine theta by 2 plus cos theta minus theta is an increasing function of theta in is an increasing function of theta in 0 comma pi by 2. Just try this. You have to differentiate this with respect to theta, because it is a function of theta, not x. I'm coming in a minute.
So I'm not sure to do this one.
Sorry.
Oh, I'm not able to do this one. I stopped at the differentiation.
You are stuck at differentiation. Okay.
Yes.
So if we differentiate this y with respect to theta, This is a function and this is a function. There is a subtraction. So we have to simply differentiate it and subtract. That is what we do. Now here in the first one, 4 is a constant. It will come outside. So you have to differentiate sine theta by 2 plus cos theta with respect to theta and minus theta with respect to theta. Now here in the here we have to apply the quotient rule because it is u by v. So 2 plus cos theta whole square. So it will be 2 plus cos theta here into differentiation of sine theta. Differentiation of sine theta will be cos theta. Minus sine theta will be there. And differentiation of 2 plus cos theta is 2 differentiation is 0. Cos theta is minus sine theta. Have you got this quotient rule?
Yes, sir.
Okay. Minus d theta by d theta is 1. So if we have 4, this will become 2 cos theta plus cos square theta plus sine square theta by 2 plus cos theta whole square minus 1. Now here what we are getting is 4, 2 cos theta, cos square theta plus sine square theta is 1, you all know, by 2 plus cos theta whole square minus 1 this will become. Fine. Now, in the interval 0 comma pi by 2, it is given in 0 comma pi by 2, okay? So in 0 comma pi by 2, should we take LCM? We can take LCM. So this 4 is multiplied to this. So 8 cos theta plus 4 it will become. And if we take LCM, we have 2 plus cos theta whole square minus 1 will become 2 plus cos theta whole square after taking LCM. So this will be 8 cos theta plus 4 minus, if you will square this and open, it will become 4 minus cos square theta minus 4 cos theta upon 2 plus cos theta whole square. In the next step, you will get 8 cos theta minus 4 cos theta is 4 cos theta. 4 minus 4 will cancel, minus cos square theta by 2 plus cos theta whole square. So this will become finally 4 cos theta common, 4 minus cos theta upon 2 plus cos theta. Calculation all is clear?
Yes, sir.
Okay. So when we see this, so 0 comma pi by 2, as they are talking about 0 comma pi by 2, which is actually first quadrant. So this dy by d theta, or we can say f dash theta, in the first quadrant, cos theta is positive in the first quadrant. Here cos theta will always be less than 1. So the whole term 4 minus cos theta will be positive because 4 is way greater than 1. 2 plus cos theta whole square is also going to be positive because it is square. So this whole term will be positive. So we can say that f dash theta is a positive quantity for theta belonging to 0 comma pi by 2, which means that f theta, which was y, is an increasing function in 0 comma pi by 2. This is what we had to prove.
Those.
Okay. Now, you can also try some more questions from NCRT. Like we are doing questions from exercise 6.2 only. So you can do this question. Sixteenth question from exercise 6.2.
So how do you know if it's increasing or decreasing?
You have to see the derivative. Derivative is positive or negative in the interval. This is what we are doing now. Have you differentiated log of sin x?
Yes, it will be cos x by sin x.
Okay, so f dash x will be cos x by sin x. Can we say it is cot x?
Yes, sir.
Now it is saying that it is strictly increasing on 0 comma pi by 2. So cot x is positive in 0 comma pi by 2. We know that. First quadrant, all trigonometric functions are positive. So cot x is also positive. And it is decreasing in pi by 2 comma pi. So cot x is less than 0 in pi by 2 comma pi. Do we know this also? In second quadrant, cot is negative. So we can see say from here that fx is positive in 0 comma pi by 2, and from here fx is negative in 0 pi by 2 comma pi.
Well done, sir.
Okay. So you can try. Similar question is 17. Would you like to try 17?
Okay. So it's decreasing in the first quarter and increasing in the second.
What is the derivative that you are getting?
Minus 10.
Minus 10, correct. So it is negative in the first quadrant and positive in the second quadrant because there is a minus sign outside 10.
Yes.
Okay, so next, would you like to try question number 18?
Okay, so so it's increasing.
What is the derivative that you are getting?
I got 3 bracket x minus 1 whole square is greater than 0.
Okay, that is 3x square minus 6x plus 3. So yeah, this is always positive for all x belonging to real number because x minus 1 whole square is a positive value. So equal to 0 is possible at x is equal to 0. So increasing we can say, strictly increasing if we can't say increasing we can say. At x is equal to 1, not x is equal to 0. At x is equal to 1, it will be 0. Fine. Do 19, last one.
Oh, so how do you differentiate e raised to minus x?
Differentiation of e to the power minus x will be e to the power minus x into minus 1. That is minus e raised to the power minus x. That is
Okay,
e to the power x is e to the power x. Further minus x will be minus 1.
oh, so I'm not sure to like reload the line. I got x e raised to minus x into 2 minus x.
X into e to the power minus x. But how do
And
we
in brackets 2 minus x.
2 minus x? So that is 2x e to the power minus x. That is fine. Minus x square e to the power minus x. That is also fine. Now it is saying it is increasing. The function is increasing. So its derivative is positive. So if you take minus sign outside, it will be x into